In our last video, we defined a few methods for ourselves. We defined turning right, asking our robot to turn right by turning left 3 times. Let's see that. Turning right, moving twice at a time. We defined what it means to turn around, and we defined what it means to back up, that you back up by turning around, moving, and then turning around again. We learned that when we call a method, we are writing the name of the file, a period, and then the name of the method we're calling. So that's the file that contains this method, parentheses, and then a semicolon every time we call a method. So for example, lesson.turnRight. And we see that even within our program. To back up, we say call the turnaround method in the lesson file, call the move method in the robot file, then the turnaround method in the lesson file. And we also learned how to comment our code, how to write that for when I call this method, it must be the case that the back is clear. There can't be anything behind the robot. And after this method has run, I don't care how it achieves it, but afterward, the robot will have moved 1 space back, and it will now be facing in its original direction. Alright, so that's commenting our code. And I want to take a look now at the format of this file, because it may be perhaps overwhelming you. How did I know what I can write where? And the good news is there's a pretty simple rule here. So the rule is that when I write one of these files, I write public class, the name of the file. I will just say file name. And usually we'll capitalize it in such a way that the first letter, in fact always, because we're good Java programmers, so we stick to Java naming conventions, we'll capitalize it in such a way that the first letter is capital, and then the others are lowercase except where we have to start a new word. And inside that file, we're going to declare methods. So for example, we'll declare turn right, or let's just say method 1. And inside of method 1, I might declare some statements, some calls to other methods, statements. And I'm not going to, it turns out there are many kinds of statements out there, only one of which is a method call. So we've seen such as a method call. And that's the only kind of statement we've seen so far. So we've got statements, a whole bunch of them. Let's just say ... so we can remember there's an arbitrary number of statements in there. And then we might have another method, public static void method 2. And it has some statements. And this would be a good time to point out, by the way, that Java is not very particular about your indenting. If I put this brace over here, it still works fine. Over here, it still works fine. Here, it still works fine. In fact, many people like putting the opening brace like that. I'm not one of those people, but you might be. So Java's pretty flexible about the punctuation of your file. You can write public and then static way down here. In other words, Java ignores white space. It recognizes that there's something separating the word from public from static, but doesn't care how much stuff, how much space or tab or new lines. Anyway, this is the format of our file. Below this, we may have many more methods defined. So in general, we have this hierarchical structure that we have a file, and inside the file we have method declarations, and inside each method declaration are statements. One of the most popular mistakes that beginners make is trying to declare methods inside of methods. And we can see here that's illegal because the only thing that can be declared in a method are statements. The only thing I can write in a statement, the only thing I can write in a method are method calls so far, or any statement. We'll see other statements soon enough. So we should be careful how we type out our file. And likewise, another popular mistake is writing statements in the middle of nowhere that aren't a part of any method. So let me show you what happens when we do those things. If we try to define, say, a method, let's say a method called do nothing that has no statements in it, which I could do, but I shouldn't be defining it inside of turn right. If I do define it inside of turn right and I hit compile, it will give me all sorts of disgusting errors, illegal start of expression. When you see that, that might mean that you've tried to define a method inside of another method. Alright, so if we did want to define that, then we should do it outside, between methods. Public static void do nothing. Of course, this is really not a useful method, but we could define it if we want. On the other hand, something else we could do that would be bad is we could ask the robot to move outside of any method. What happens when I do that? I'm hitting compile now, I'm hitting F5. When I do that, it tells me identifier expected, which is an extremely unhelpful error message. We have no idea what that means. So when we see an error message, it's going to tell us where something went wrong, but Java's not very good at explaining to us what went wrong and what we need to do to fix it. So we really need to make sure we stick to the rules of the grammar. And the grammatical rules for Java dictate that we have a file with method declarations in it, and inside those method declarations we have statements. And it's going to turn out there's other things we can put in our file, and we can make a mess as we learn more and more of Java. But for now, we'll stick to this simple hierarchical structure, and we'll know that if we go astray, we get ugly error messages that are not particularly helpful. Why aren't the error messages helpful? Because Java is an industrial, professional language, and that means that it's not meant for beginners, even though we tend to teach beginners Java. It's meant for professionals who understand what those error messages mean. And in some cases, it's not even helpful to professionals. Alright, so we've got, we understand what we're allowed to write where. What happens when we actually use a method? Suppose that I define turn right. Let's go ahead and do that again. Public static void turn right, and it consists of 3 calls to turn left, robot turn left, robot turn left, robot turn left. And then somewhere else in my program, I actually call turn right. Maybe I write, I would like to, actually, suppose I don't for a moment. Suppose I say, I'd like to move, and then turn left, turn left, turn left. Suppose I don't realize I should be calling my turn right method, or maybe I haven't defined it yet. Java will execute these instructions in a linear fashion, one after another, in order. It's very straightforward to look at this code, look at this sequence of instructions, and know what it is going to do. Now suppose that I get smart, and I define, actually, I would like to move, then I'll call turn right, which we'll assume is defined in my lesson file, and then I'll move again. When I do that, something interesting happens. I say move, I say turn right, and Java's going to stop and say, what does turn right mean? And it will look it up and discover, oh, turn right means turn left 3 times. So Java's going to look up the method name, find the definition of that name, find what turn right means. Then it will proceed to execute the body of that method. And in this case, the body means turn left. Uh-oh, we're getting off the screen here. Maybe we'll start abbreviating. There we go. Means left, turn left, turn left. Perform these 3 instructions one after another. And then having turn left 3 times, we're going to go right back, return to the previous method, return to wherever it was we left off. And actually that happens anytime we call even move. When we call move, Java stops and executes the code inside the move method. It looks up move, it executes that code, it comes back to this point, and then it turns left. Or in this case, turns right, which involves looking up turn right, which involves executing the body, turn left 3 times, and then go back to this point and move. So you might wonder, wait a second, doesn't that mean methods are bad? Because look how simple it was for Java to run turn left 3 times, and look how much work we're making for Java to look up turn right, and then run what's inside turn right, and then remember where to come back to, go back to it at the end. Aren't we making a lot of work for Java? And the answer is yes. So here's the trade-off. We do less work, because once we've defined turn right, we can reuse the methods we define. On the other hand, the computer does more work. It has to stop, it has to look up that information. It's possible that it takes more time to look up that information depending on what the compiler actually does when it translates our program into Java bytecode. So is this a good trade-off? Do we want to do less work and make the computer do more work? And the answer is usually yes. We love when the computer does more work and we don't have to. So we're going to consider this a positive trade-off. There may be times when we're concerned that the computer might be doing so much work, and we're concerned it will run for hours, and if we do a little bit more work in our program, it will run faster, but that's going to be the exception to the rule. Usually, we want the computer to do more work so that we don't have to. That's what computers are for. That's why we created computers and enslaved them to do our bidding. So this is an excellent trade-off. Okay, I think that concludes our understanding the fundamentals of what methods really are. In the next video, we'll start solving some more interesting problems and see just how much power breaking problems down into methods gives us. I will see you there.